My name is Nandan. I'm a PM with Apigee, and I'm going to be talking to you guys a bit about API management and microservices before I introduce Galo from HP, and he's going to talk to you guys about how HP used microservices and API management in their transformation. So let's start off very quickly with why enterprises are building microservices-based architectures. What's the driving factor? Our two main reasons come to my mind when enterprises are talking about microservices. The first is that they want to take advantage of cloud-based infrastructure. Now, we may all not agree on what microservices are, but there's general consensus on what a microservices stack looks like. And the general idea is that by building your applications or workloads to be compatible with this architecture enables you to move these workloads to the cloud. Even if they don't move right away, it gives the companies choices to move to the cloud. The second big idea behind microservices, and we hear this all the time, is velocity, speed, agility, and all of this, right? And the problem with monolith applications where it took forever to test, it took forever to make production releases, and microservices promised an architecture where you had the agility to make deployments faster. So as enterprises started decomposing their microservices into independent units, developers got the chance to independently develop, deploy, version, scale those services and these are problems that you didn't have with microservices. So in theory, we should come to the conclusion that yes, microservices are awesome, all problems were solved. While it is true that the challenges with speed and agility were definitely solved with a microservices architecture, new problems were introduced, right? When you had all these development teams building microservices, governance became a big issue. Like, where do I do MTLS? Where do I do load balancing? How do I ensure that the right telemetry is collected? Or there's a performance issue. Every microservices team says, yep, my service is doing just fine. And so we saw the advent of service management tools. And so a service management tool is really catered to the persona of a service operator. A service operator is someone who's concerned with the fleet of services that he or she manages, and they're interested to apply governance across these services. That governance standard could be MTLS for all my services. I want to capture telemetry, not have every microservices team invent these concepts for their microservices, nor have these things put into the code base of your microservices. Start to think of these capabilities as available in the infrastructure itself. So I get features like governance, observability, and basic security into each of my microservices. So imagine that you have microservices and you're using a tool that gives you these capabilities. Is it done? Is there anything else that is missing? Well, when you think about it, yes, we have solved the problem for a service operator who's looking at these services in production. But before services get to production, there is a set of capabilities that we need for producers and consumers. So teams that are building microservices are often building microservices that are consumed by other teams outside your zone of trust. Those other teams could be in other departments in your organization, could even be outside the enterprise. So when you have teams outside your enterprise who are consuming services, where do they find your microservices? How do they know what the documentation for your microservices looks like? How do they get access to these services, and how do you manage that? So the concept of managing the relationship between producers and consumers is critical to API management. So a consumer of your microservice should go to a portal, seek access to a microservice he or she wants access to, because they're building other microservices based on this. And now comes the concerns of a provider. As a provider, I want to manage who can access my microservices. I want to be able to revoke their access or grant access. If I am granting access, I may want to grant different degrees of access to my microservices. I'll build a microservice once and have different degrees of access to internal consumers versus external consumers. So at one point, yes, as a developer or as a producer, I want to engage consumers. I want to control their access, and then also control what type of access I want to give them. So once you've defined who gets access to my microservices and how they get access to it, the next step, obviously, is to enforce that access, policy enforcement. When we think of policy enforcement, we really think about a gateway. A gateway is typically a place that's where you do policy enforcement, also known as policy enforcement points. And when you think about API gateways, this is a picture that comes to mind, or capabilities that we all expect API gateways to have. You want your API gateways to do things like rate limiting or spike arrests. You want those gateways to verify tokens. You want the gateways to even provide other features not related to security, like caching of requests or responses. These are all things that we come to expect of an API gateway. And when we talk about API gateways, a pattern that has served for many years is this sort of a centralized API gateway. These cluster or groups of API gateways often served as a single entry point into your APIs. Right? API.companyname.com would really be the one that's receiving the requests, which is a group of gateways that are a facade to all your APIs. And these gateways did functions like rate limiting, checking the token, did all this in addition to more advanced features like aggregating a bunch of services to give you the facade as if they were one. They also orchestrated other microservices or services, and they performed that function fairly well. But when you start thinking about using this pattern for microservices, something doesn't always fit right. It is not uncommon for a single transaction from one of your channels to a backend go through a number of microservices before it goes to the database. And as it goes through your microservices, it is onerous to have every microservice go back to a centralized gateway and hit the database. Clearly, that's not a viable option. And so to deal with this situation, we now see patterns that are sidecar API gateways. Sometimes they're also referred to as micro gateways. So a sidecar is a process that runs in the same trust zone as your microservice. You really have to think about it as an extension of your application. It's not something else, but is a separate process. And the application, or the microservice in this case, delegates certain responsibilities to the sidecar so you don't have to implement it yourself. And a sidecar gateway is ideal for implementing allow-deny type of rules. What are allow-deny type of rules? Rate limiting is one. Do I allow traffic? Do I block it? Checking a token or a key is an allow-deny rule. Do I allow this access or deny this? And they're perfect for this sort of a scenario, which is typically what we see when you have microservices calling other microservices. So does that mean that that's the only pattern that fits microservices, that everything is a sidecar gateway? Well, our position is that you don't necessarily have to choose. You could have an intelligent ingress that is able to decide for every API, should this API be enforced by a sidecar, or should this be enforced by a more centralized gateway? And you could use various techniques to discriminate what type of a gateway needs to enforce policies on this. So based on a verb, a path, or something in the header, you could route traffic to a centralized gateway to get more advanced functions for it, because that API needs it, or it could be directly routed to a sidecar because that is all what was needed. There will be some cases which really go through both gateways, and that's perfectly fine too, as long as you're not duplicating functionality. So the other thing to remember as you're building microservices is that not everything in your enterprise is going to be a microservice. Yes, sure, you're all in the transition phase where you're building applications in that, but there are also other types of applications in your enterprise. Most enterprises will still have a good set of SOA-based services that they're trying to modernize slowly. Enterprises are being forced to expose a lot of their APIs to the public. Standards like open banking are forcing banks to have public-facing APIs, things that didn't happen 3-4 years ago. So as an enterprise, you're going to have a combination of all these requirements. Also, not uncommon is for enterprises to invoke APIs built by other vendors. Salesforce, Workday, these are all APIs that you want to make available. It's not really nice to have your microservices developer get another OAuth token for Salesforce, get an OAuth token internally, and have to manage all this. it would be really nice to have some sort of token mediation so your microservices developer deals with one type of an access token that gets mediated between different types of standards. So our recommendation is that when building microservices, use a service management tool. And most service management tools like Istio or Linkerd, they come with a sidecar. And as much as possible, use the sidecar to act as your Sidecar API gateway. So in the case of Istio, Envoy would be that sort of a Sidecar API gateway. And for cases where you need a more centralized gateway, think about a centralized API management platform that is able to offer these capabilities. So Apigee has a gateway that gives you capabilities for all these form factors. We have the enterprise API gateway that we have now had for about 6 or 7 years, and it's been running in production with many of our customers. But we have also introduced 2 types of gateways, the micro gateway for customers who have not yet adopted a service mesh like Istio. And we've built the Apigee adapter for Istio for enterprises that have started to adopt Istio for service management. The key point here is that the API management platform becomes a central control plane through which you can control different classes of gateways depending on the needs of your enterprise. So with this quick introduction, I invite Galo now to talk about how HP use some of these technologies at their enterprise.
Okay.
Galo?
Okay, thank you, Nandan. Okay, so my name is Galo Gimenez. I work at HP at the office of the CTO, where we are basically building infrastructure and core services that support our devices and our applications. I've been in HP for more than 20 years now, and during those years, almost 15 years, I've been basically building distributed systems. So I won't go into the numbers. HP was a company that was founded in 1939, so it's a very old company for Silicon Valley. In 2015, the company was reinvented to focus on 3 areas. One is basically edge computing, so things like workstations and Chromebooks. The other one is printing, so we do things from $29 printers to several $1 million printers. And the last one is 3D manufacturing. One of the important things that we have here is that HP is operating in 170 countries. So that means that compliance and privacy regulations are an important aspect of everything that we do. And I'm going to basically talk how we use the cloud and the service meshes and proxies to do that. So in HP, there is like 3 trends that are affecting the way we do things. One is what we call One Life. One Life is basically the blending of our personal and professional lives. So we use the same devices for work and play. The other one is as a service. So the go-to-market is changing from transactional to contractual. So you can see this in IT organizations offloading their operations to other groups, so basically they don't have to deploy, manage, and secure services. And the last one is security and privacy, which is obviously with more devices connected, consumers and organizations are basically consuming and producing very valuable data that we need to protect. Okay? So these trends basically set the direction of our organization, and then in our organization there are basically 2 groups that have a big say on how we do cloud. One is IT. IT, with the change in 2015, decided not to focus anymore on data centers and migrate everything to the public cloud. And obviously IT traditionally focuses on security and cost. My group, the CTO office, basically traditionally we focus on things such as innovation. We try to bring best practices from the industry into the tech communities in HP. And then because we are a neutral organization, we took on the work of doing these shared services across all the organizations. Finally, my group is very focused on privacy and security, especially for global applications, because all the markets where we are. Oops. So, sorry, I need to go back. So this basically defines our strategy for how we do cloud. I mean, there is nothing that should surprise you here. So basically, we are cloud native because we are in the public cloud. We do agile, we do continuous delivery and integration, we do DevOps, and because we have these shared services, contracts are very important for us. And for us, contracts are basically APIs and SLAs. Security and privacy, as I said, is a very important role for both IT and the city office. And finally, microservices is part of our strategy, and what I'm going to explain to you is how we do microservices in HP and why we do it. Okay? So why we do microservices? The real reason is basically product velocity. We are building these applications. Initially, those applications were built by very large teams with many people, and this required a lot of synchronization between those teams. These teams, usually in different functional areas of the application, will have dependencies across them. And sometimes the dependencies were circular, so basically this required even more meetings to solve those dependencies. We had these continuous integration pipelines that will take hours, and because there were so many dependencies, there were manual gates to decide if something was moving or not moving forward, right? So at the end, the result was that features will take very long, much more longer than what all we wanted to put into production. So with microservices, what we were looking for was to increase the product velocity. So we have a smaller code base that our teams can handle. We try to have those smaller applications and services go into production independently, so they don't have to have dependencies with other teams. We have smaller teams, so the communication in those smaller teams is less. So we have less communication. It's more efficient because we can have those smaller teams usually co-located. And then because they are smaller teams, they can own the whole application stack. So they can own how the application is developed, coded, tested, moved into production, and they are usually operating those applications themselves. So they are on pager duty, they get the alerts, and they own the whole thing. So we call it, you build it, you run it. But when we started to do microservices, obviously microservices are more complicated than monolith applications. Microservices have lots of technical problems. So the first one we found was infrastructure cost. Suddenly we have all these VMs, right? And these VMs became very expensive because we had many of those VMs for every single service and different environments for every service. We had dozens and dozens of continuous integration pipelines, right? Because now you have many, many, many services. Orchestration and discovery becomes way more complicated because services depend on other services, so you need to know where the other service is in which environment are you running, are you in production, are you in QA? And basically you have to depend on the other service to be there in order for your service to start working. There is challenges that are traditional and normal in distributed systems. You have latency variants, you have network partitions, you need to deal with distributed transactions across different services. So those are very hard problems to solve sometimes. We have problems with dependency versions. Now you have services that depend on other services, and those other services have new versions continuously. So how do you know which is the other version of the other service and when the other team changes the version of the service? Integration testing became really, really difficult because now when you release one of those services, you need to do the integration testing with a bunch of other services. And finally, the problem which I'm going to focus now is basically policy spread. So this is an example of an application with 7 microservices. I call them A, B, and C. And usually you are going to have that you have more than one version of those services. So we call them alpha, beta, gamma, and so on. Okay? And these services might be managing different types of data. Some of the data is personal. Some of the data is data that is not sensitive or doesn't contain personal information, and so on. Okay? And your mesh, and you might think that this is a very complex application, but as soon as you start to do microservices, you will find that it's very easy to get in a complicated mesh like this. Now, you will end up deploying this application in multiple data centers or Kubernetes clusters, wherever you deploy, and your mesh might even get more complicated. So you will have, on top of A, B, and C, and alpha, beta, and gamma, you are going to have A prime and alpha prime, right? And the decision of where you deploy things in the different data centers, it might depend on cost considerations or latency considerations, right? So this mesh is going to be then to get more messy and complicated. So when you look at the things you need to do in all of these services, you will see that you are repeating things over and over. So basically, you need to apply things such as authorization, authentication. You need to do payload inspection. You need to do rates. You need to do quotas, right? And you do this over and over and over and over on every single place. In the worst case, you are going to be doing this in different languages because those services might be implemented in different languages. Some might be Node applications, some might be Go applications, some might be Java applications. So at the end, you have policy spread all over the place. It is very difficult to understand what is your position about policy. You don't have any visibility about what is going on in the system. And worse, it is very easy to have a single mistake that is going to screw up yours. Basically, it's going to bring your system to a very bad situation. So, good news is there is things that can help to solve these problems. So, one of the technologies that helps are containers and Kubernetes. They basically help us to have more density in our deployments. They solve us some of the problems around orchestration and discovery. The other one is API management. So now we can have written contracts with the consumers of our APIs that we can version, and we can have visibility about how our consumers are using the APIs of those different services. We have API gateways and proxies that basically allow us to centralize some of the policies, as Nandan described before. So we can have things such as authorization and authentication centralized in a single location, or payload inspection. And finally, with the service mesh, we can go further and have additional network policies implemented by the mesh. So we can have things such as traffic encryption, or basically balancing between services and so on. Okay? So I'm going to focus on the last ones. So in HP, we have different applications as everybody. So we have everything from legacy to very new applications. And we have these three different models, as Nandan described it, about how we do these things. So the first thing is we have monolith applications. These applications, sometimes they are deployed in Kubernetes clusters. Sometimes they are deployed in VMs, right? But we still need to have this common control plane where we want to put the policies. In this case, we use this centralized proxy that basically takes the policies such as authentication, authorization, and rate limits, and that's the location where we are. In the case where we have this in Kubernetes, or in the case where we have in VMs, there is no difference, right? Newer applications that we started a few years ago, we started to use the sidecar container paradigm. So basically, we embed a micro gateway in front of our services. So basically, our continuous integration pipeline, when you deploy one of those services, injects a sidecar container into the pods. And that sidecar container, in our case, we base it on Apigee's micro gateway. It's connected to the Apigee control plane, so we can manage some of the policies there. Now, many of the policies we cannot manage through the control plane. They need to be embedded into the micro gateway itself. So basically, our continuous integration pipeline configuration management mechanism is making sure we have the right policies there. Still, this is a little bit problematic because basically the micro gateway for service A and the micro gateway for service B might be different, right? So the last services that we are building, we are leveraging Eastham. The difference with the previous model I showed you before is now that you have this common control plane where you can manage a very large fleet of micro gateways or proxies. So you have all the policies managed in a single place. So you don't need to have different versions of this micro gateway for the different services. You can manage this centrally. Another interesting thing about Istio, it provides just not policies on the ingress, but you can have policies also in the egress. So you can control to whom your services are talking, or you can whitelist or blacklist some services where you don't want the traffic to go. Okay? So I'm going to show you a couple of applications where we use this. So this is one of the largest applications that we have right now. It's HPD. Basically, HPD is the HP Identity Management System. So if you go to hp.com, or you have a printer that is connected into the cloud, your identity is managed by this system. This application right now is running in 3 data centers. Basically, we have 3 regions, and we have a Kubernetes cluster in every region. In this case, we are using the micro gateway model. You can see these orange bubbles there. That's the micro gateway that we inject in front of the services. And the traffic is sent to the clusters through an ingress. In this case, we are using Nginx. You will notice that some of our pods have just the micro gateway. And the reason is we have some backend services that still run on VMs. They are not in this diagram. And we also proxy the traffic to those services through micro gateway. So basically, we apply a consistent way of, we have a consistent way of applying those policies to everything that we have in our infrastructure. In this case, we decided to put the micro gateway in Kubernetes because it's, for us, far easier to scale, to manage, and to release than having those micro gateways deployed in VMs with the services that are in the backend. Okay? This is another application. This is our content management system. So most of our devices deal with content, scan or printed content, and the content goes through the cloud, and this system basically is what manages that content. So in this case, the system is deployed to data centers, one in the US and one in Europe, and we are basically using Istio. So what we are basically doing here is we replace Nginx by the Istio gateway, so all the traffic goes into the Istio gateway, and then we have Envoy injected automatically by the Istio system in front of our services. The good thing about Istio is that Apigee has integrated this with their control plane on the cloud. So basically, we can have consistent authentication and authorization policies for all of services, independently of what is the mechanism we use to deploy those services. And that's it. I'll let Nandan.
Thank you, Galo. So obviously, we can't show you the actual systems that HP uses, but we've got a demo that kind of shows you these technologies and how they kind of come together. So in this demo, we took a simple example to illustrate the point. It's a retail example that has a bunch of services, right? The first is there's an order API, and you have a consumer that's outside your zone of trust. Could be a mobile app, an online app, whatever it is that's making a request to the order API. The order API calls the inventory microservice. They're both built as microservices, and that shows you some service-to-service connectivity there with one of these services that's exposed outside. And depending on certain conditions, the order API could also invoke and place an order on Salesforce with a partner, and that's how they've exposed their interface with this order API. So what this example would look like when actually implemented with gateways is that you would have a common ingress point to this application, api.retailcompany.com. Right? And your order APIs are obviously, that's the facade that the request comes to. And then the ingress then decides what to deal with this or how to deal with this API request. Now, because this request is coming from the outside, you generally would want to scan the payload to make sure the JSON's well formed, does not exceed certain capacity, and you want to do this general check because it's coming from an untrusted network. And that's what you see as message processor. That's the name for Apigee's centralized or enterprise API gateway. The gateway then hands it off to the order microservice. All of these are running in Kubernetes at this point. The order microservice then calls the inventory microservice, but except this time, it does not have to go back to that centralized gateway, even though it's in the same cluster. It now calls the micro gateway, which is the only facade the inventory service exposes, so there's no way to bypass the gateway and go directly to the inventory service. And of course, there's now a call out that the order API needs to call Salesforce. But obviously, I don't want the order API to code for Salesforce's access tokens and all that. It's already got an access token with it, and that's all it uses to call Salesforce. So this time, when the order API invokes this vendor's API, it calls that API without knowing what this vendor's authentication authorization mechanism is. But the centralized gateway manages this token mediation and does this on behalf of the order API. And of course, at the end of all this, we're going to see some analytics to see how all these APIs are being used, who's using them, and so on and so forth. All right, so with that, let's go see the demo. Demo, please. All right, so I've got a single Kubernetes cluster on GKE where I've got my applications and microservices installed, and I'm going to use my CLI to show you what exactly is running. Let me go here. So I'm going to quickly show you the actual microservices. So demo is the namespace I have, and this is where I've got those two microservices. I don't know if that's big enough for you guys, but if you guys can see, no, OK. I wish you hadn't said that because I don't know how to increase the font. Sorry, I'll read it out. Right? There are two microservices there, the order and inventory microservice. And I know it's hard to tell, but one of them is a pod with two containers in it, one of which has the micro gateway. Okay, so now that we've seen the applications that are running, we'll very quickly show you the Apigee components that are running also on the same gateway. This uses the recently announced Apigee Hybrid, which runs the enterprise gateway on any platform of your choice. So this is running now on GKE. So I've got all my gateway infrastructure running in a remote installation that's now getting instructions from a central control plane that's managed by Apigee. So I've got my Apigee components running. It's also got Istio in it, and we'll see how they work together. Okay, so now what I'm going to do is I'm going to try and gain access to a pod just to kind of show you to see if I can bypass some of the security systems and access these services. So usually you would restrict such access through Kubernetes ACL, but this time, just to show you that the services are indeed protected, I'm going to get into one of these services. I've gotten access to one of the pods, and now I'm going to try and access the service directly. So I'm going to call the inventory service from a pod that's running in Kubernetes, and if everything works good, I should get an error message. I get a missing authorization because even though I'm inside the cluster, I'm running in another pod, I can't access it because there's a sidecar gateway that's protecting all of these microservices. But if I got access to the inventory service, I should then be able to get access to it. So now if I change my persona from being a service operator who was worried about this to being a developer of the order service who wants to invoke the inventory service, what I would do is go to the developer portal, right? And now this is a quick example of the portal that we have, and I'd go look at all the services that exist in my catalog. And now you can control access to what microservices I should see. Internal developers probably will see most of the catalog, and external developers may not. And once I have seen the APIs that I'm interested in, I could even try accessing some of these APIs from here, see how they operate. So for example, I'm going to take order as an example here. Although I'm building the order service, in this example, I'm going to assume that I want to consume the order service. I'm going to quickly try and gain some access to it, look at how the API works. I see the response. I get some documentation about it. It looks like I'm mostly good to start building my application based on this. But there's one important step missing. I never got access to this API. And that's what I'll do next, right? Now, of course, I pre-created these, but what I would do is go to my application access and then look at, and then request access to the APIs here. So here I already pre-created this where I've gotten access to the order application. I've got a client ID and a secret, so I can get my OAuth tokens for it, and I can use these tokens to access my service. And this is what a typical developer would do. Now, assuming I've got this client ID, now I'm going to try and access the inventory service because I now have credentials to access that service. So this time, I'm going to go back to the same Kubernetes pod, but this time I'm going to access it with a key. So now that I access it with a key, I get an HTTP 200 back. I could use -v, and then you guys will see the response. It's kind of unfortunate that the font's not big enough. My terminal doesn't support changing that. Sorry about that. Okay, so now that we have kind of protected my east-west traffic, microservice to microservice communication, let's take a quick look at how I would protect it for traffic coming from the outside. So what I'm going to do next is very quickly show you how that setup looks like. If you look at the containers that I have the inventory container and the micro gateway container in the same pod. So the micro gateway will scale and get upgraded each time I deploy the pod for inventory. Okay, so now let's go take an example about trying to access a partner API. So in this case, that partner API would be Salesforce. I'm not even going to try and send a parameter to it. I'll send an empty body to show you that the partner's API is protected. So I'm going to send this empty string to the partner API. You'll notice two things. First, that wasn't a Salesforce endpoint. I used Fazio. Fazio is the name I made up for the retail service. So I still use my internal host name or domain name to access this API. The second, it was protected, and so I got access denied because I didn't have the tokens to access it. Now, what I would again do is go back to the portal and seek access to this API like any other API in my enterprise, because I don't care what the partner implemented. So now let me go grab a token. So I'm going to connect to my token endpoint and pass in the client credentials down because that's easy to show. And I'm going to go get an access token for it. So now that I've gotten this access token, I'm going to try and access the partner's API now. And let's paste that. And put the token in. And send in the body. Yep. All right, so my order was submitted. Now I'm going to quickly log into Salesforce and show you that my order got created. So if everything worked fine, I had 15 orders. I'm going to do a quick refresh. Hopefully there's a 16th one that just came in, and that was created through the enterprise gateway that I just created now. So there's a quick demo to show 3 different use cases, some east-west traffic being protected, north-south, and some token mediation. Thank you all.